I'm very happy to introduce Thomas Topel, who is doing a DPhil at Oxford in information theory and theology. He's going to bring together the thinking of a giant in nuclear physics of the last century, Carl Friedrich von Weizsacker, and one of the most notable theologians of the last century, Wolfhart, Panneberg. Over to you.
Thanks so much. Thank you. Wolfhart Panneberg, in discussing a Trinitarian theology of creation, asks if the close partnership between Logos and Spirit in the making of the world can be expressed in terms that take account of modern science. As he does often in his reflections on natural sciences, Panneberg here turns to physicist and philosopher Carl von Weizsacker. If von Weizsäcker's suggestion is followed, Panneberg remarks, namely that the ancient philosophical Logos doctrine can be reformulated in terms of modern information theory, then it does not seem completely inconceivable that a field theory of information can do justice to the cooperation of Logos and Spirit in the creation of the world. The purpose of this short talk is to examine one aspect of Weizsäcker's thought on which Panneberg grounds his suggestion that a field theory of information may offer a more adequate language in which to express a Trinitarian theology of nature. The point of focus will be Weizsäcker's notion of the alternative, what today we call a quantum bit, and the way it serves to unite the subjective knower and the objective world within his rational and informational reconstruction of quantum theory. On his hypothesis, particles, fields, and space itself are built from so that at the most basic level, nature, of which humanity is a part, consists of information carrying qubits. This will then be connected briefly to Panneberg's doctrine of creation. And note the amendment from the submitted abstract to tighten things up. I turn first to an overview of Weizsäcker's central ideas. I will present these as 7 major and quite striking claims. Weizsäcker's work has as its theme a single philosophical idea, that of the unity of nature. By nature, Weizsäcker intends the constitution and course of things, or more broadly, the character and quality of the world. This nature, moreover, is to be identified with Aristotle's physis, what carries in itself a principle of motion. Thus, for Weizsäcker, physis, or physics, is that comprehensive science of nature whose perimeter is larger than the contemporary discipline with that name. Of this physics, he asserts an encompassing unity. Indeed, this is almost a tautology, since to claim that physics in its essence is a unity is, for him, to say none other than nature in its nature is a unity. Weizsäcker's project then begins with this first claim. There is only one nature. On this conception, all scientific disciplines overlap not merely in their methods, but fundamentally in the unity of their object. As we will discuss shortly, this object is none other than information. And crucially, because information relays knowledge between an object and a subject, information serves, in Weizsäcker's framework, to unite subject and object. We might frame this as the second major claim. Nature is its own method. Weizsäcker's physics of information, if it can be constructed, would describe a rich and cohesive monism. But can it be constructed? The question surrounding the possibility of a unified science leads to the philosophical reflection concerning the very possibility of science. How, as Weizsäcker, is physics possible? As an empirical science, physics rests on experience. The question then becomes, how is experience possible? Weizsäcker's programmatic answer involves the historic character of nature. Human experience is a process in time. That is, we learn in the present, from the past, for the future. But the historicity of our existence, already presupposed in the concept of experience, is possible only because we emerge within nature, and nature itself is historical. And what is history? Well, in the broadest sense, it is the essence of what happens in time. Nature being in time is without question historical, but something further is intended by claiming a historical character for nature. More narrowly conceived, history concerns irrevocable change. A third claim then. Time is the most fundamental feature of nature. Nature is historical. That is, as a whole, the universe is irreversible. The structure of time, therefore, is one of the preconditions of the possibility of experience. Indicated here is Weizsacker, the student of Kant. But he goes further than the teacher in developing his claim that the general and therefore unifying laws of physics formulate neither more nor less than the possibility of experience itself. For the unity of nature is, for Weizsacker, based not on Kant's unity of apperception, but on the temporal structure that underlies this. Science is experiential, and experience is historical, hence the basic character of the temporal for all things empirical. The unity of nature, understood as the unity of physics, becomes for Weizsacker the unity of temporal experience. Weizsacker then holds to a rather healthy empiricism. Physics concerns knowledge won on the basis of past events, and this knowledge is, one anticipates, applicable to future events. The past is factual, the future is open. What does it mean to say that the future is open? In mathematical terms, it is to invoke the language of probability. For Weizsacker, probability, and he means objective probability, by its very nature is a temporal concept. One can ascribe a probabilistic statement only to events pertaining to the future. Furthermore, information in a quantitative setting is typically defined in terms of probabilities, generally some logarithm over a probability distribution. Information then, too, is a temporal concept. To state that probabilities are objective, or to say much the same, that they can be measured, is to implicitly answer the very deep question, how the world is given. For a probabilistic event is a determinate concept, a repeatable occurrence whose outcome is indeterminate. The outcome themselves must be objectively possible and empirically decidable. And in order to be repeatable, the event must be time bridging, to use Weizsäcker's phrase. That is, an object or event must at different times always offer the same potential results or properties. A probabilistic event then is an objective, time-bridging alternative. According to quantum theory, most every event is, at bottom, probabilistic. Weizsacker gives the name n-fold alternative to a complete list of n mutually exclusive temporal propositions. The propositions are the answers to the alternative, which can in turn be understood as a question. The answers are temporal propositions in the sense that in their simplest form, they state something about the present, though they can be formulated so as to apply to some past or future time. This notion of alternative can be defined purely logically. The concept of an object can then be reduced formally to that of a time-bridging alternative. Alternatives are considered decidable without investigating how the decisions are realized. Each is merely characterized as empirical, that is, depending on particular contingent phenomena that may or may not occur. Just what may occur, this is regarded as being formulated by physical theory. Physics then, what Weizsacker here calls abstract quantum theory, the most fundamental physics, itself provides the list of formally possible temporal propositions, which formulate what may at all occur at any time. Weizsäcker's fourth claim is thus, every object is uniquely characterized by a number of time-bridging, empirically decidable alternatives. Conversely, whatever can thus be characterized is called an object. The concept under which an object falls is defined by the conceptual detailing of the alternatives characterizing that object. So we might think of this as kind of a quantum-inspired category theory, which, whether it could be carried out in practice, he thinks is there in principle. Presupposed here is that alternatives can be characterized and recognized conceptually. That is, on the basis of their immanent structure, so number of answers, subsummation under perhaps a mathematical state space, etc. According to the meaning of their answers, so linguistic articulation, etc. And also individually, so I measure something here and now with a particular index. The world, in other words, is given conceptually. Just how this characterization is done, says Weizsacker, is a question of phenomenology. Here, he merely argues that there is no necessity of assuming objects that do not fall under this conceptual science. For such purported objects, which would not be delineated by conceptual means at all, and thus not subject to physics, precisely because of this designation in terms of alternatives must be subject to physics after all. Another claim thus follows. The limits of physics will have to be the limits of conceptual thinking itself. So in all of my text here, physics is capital P. So he's dealing with, like I mentioned in the start, his conception of physics is all-encompassing, biology, information science, etc. In this sense, Weizsacker notes, we already presuppose that there is such a thing as knowledge. Physics, then, is something like a conceptually articulated, tense logic, another major theme of his. The concept, in turn, is related to form. And here we're talking about that ancient notion of eidos, or idea, whose measure, on Weizsäcker's view, is information. One can state objectively the amount of information in every measurement of a quantity described in advance as formally possible. The concept as subjective knowledge corresponds to the form which is known objectively. We therefore expect to be able to measure the information of an object to the extent that we can subsume it under a particular concept. One can define the quantitative measure of the form of an object as the number of simple alternatives that must be decided in order to describe this form. Claim number 6 therefore states, the information contained in an object measures exactly its amount of form. Lastly, Weizsäcker proposes what he calls the identity hypothesis. This states that consciousness and matter are different aspects of the same reality. With this, we arrive at a final claim. Events in consciousness can be described in terms of those self-same time-bridging alternatives. Since it is form that is known, the objects of nature and the events of consciousness are intrinsically informational. I close out this section by addressing a potential worry. It may seem that we are spiraling into subjectivity. After all, of whose information are we speaking? Information about what? Whose time? Whose history? There is indeed a spiral. Let me explain. A division between humanity and nature cannot, for Weizsäcker, ultimately hold in reality. There cannot be a division between humanity and nature. Natural science as a conceptual framework is to be seen as a product of human achievement. In this way, humanity precedes the sciences. Yet, grounded in the natural world, humanity is a part of and emerges within nature, so that nature precedes humanity. Such reflections lead Weizsäcker to an important figure of his method, the circular course, or in German, the Kreisgang, whose two half circles are variously subject and object, humanity and nature, knowledge and being, idealism and realism, or the humanities and the sciences. In traversing many times the two semicircles, in the semicircle's closure, their mutual engagement and the dependence of the two sides appear. How nature knows and what is thereby known, and the connection between these processes in the temporal frame in which they unfold, this is Weizsäcker's encompassing, or better, encircling theme. If the first semicircle is marked by a transcendentalism, a Kantian transcendentalism, such that nature depends on the subject, the second semicircle embraces a naturalism. The subject depends on nature. Probability and information must be taken as both objective and subject-related concepts. Their meaning, Weizsäcker contends, is nothing less than the quantification of knowledge. And knowledge is always knowledge someone has of something. The increase in knowledge gained as the result of an event, that is, the measure of information, clearly depends on one's prior knowledge. Information, therefore, relates knowledge and experience of the world, form and time in the world. Information unites subject and object. Does this fit together with the above claim that information measures form? It does for one who, like Weizsacker, embraces the ancient rule that form, or eidos, is precisely what can be known. Form, we might say, informs the informed. As we have seen, Weizsäcker's philosophy of physics is founded on temporality and distinguishability, the possibility of making conceptual distinctions within the empirical and temporal domain, which is inherent in the notion of an alternative. Together, these lead to the notion of a time-bridging alternative. Weizsäcker claims that every object is uniquely characterized by a number of time-bridging alternatives. The simplest such object is a twofold alternative, what Weizsäcker calls an alternative, where here is the German word for elemental, primary, archetypal. An alternative is the most basic, empirically decidable alternative. It is simply a yes-no decision, a two-level system. Of course, because nature is quantum mechanical, an alternative is a qubit, a quantum bit, which is to say a superposition of 0 and 1. Theory is the name of Weizsäcker's basic framework for a philosophically motivated reconstruction of the whole of physics. Let me skip forward a bit. Let me simply say that his theory is based on two central tenets. One, information theoretical atomism, so the prediction that all empirical sciences can be reduced to the smallest units of binary alternatives and permit a decomposition of state spaces into atoms of information. Two, crucially, symmetry, so that the smallest possible non-trivial state space of a quantum theory, which would be a two-dimensional Hilbert space, permits a symmetry group which first itself represents a three-dimensional real space, and second is the basic space going into a larger space formed by direct products. In short, he wants to say that information and the symmetry that would characterize the state space of those alternatives can build not only elementary particles, but space itself. To wrap up with Weizsäcker, I quote, "I conjecture that elementary particle theory and cosmology are already logical consequences of a quantum mechanics in which one requires the forces themselves be described as objects, that is, in the end, as fields. It should then be possible to construct elementary particle theory from the theory of the simplest possible objects permitted by quantum mechanics. These would be the only atoms in the original philosophical sense of strict indivisibility. Objects of this type would be defined by a single measurement, an alternative, a yes-no decision." Against this background, then, let me conclude by briefly turning to Panneberg's theology of nature. Most explicitly, Panneberg draws on Weizsäcker's thinking in a number of essays composed in the 1970s and 80s. You can refer to his collection Toward a Theology of Nature, and in Volume 2 of his Systematics. I can point out here only the most relevant consonant claims. Panneberg asks if a theology of information can offer a more scientifically adequate language in which a Trinitarian theology of nature may be expressed. Can it capture the cooperation of logos and spirit in the creation of the world? What might this entail? First, for Panneberg, the act of creation has a Trinitarian ground. The spirit is the source of creation's dynamic. The Son is the source of creation's distinctions. The spirit can be spoken of as field, the logos as information. Their cooperation in the world moves the things of the world towards the Father, toward fellowship with and participation in the divine life. Reflecting on the mediation of the Son in creation, Panneberg ascribes to his working the diversity and coordination among created things. As the quintessence of such distinctions and relations, he writes, the Son is the logos of creation, the origin and epitome of its order. Now, the concrete order is related to the incarnation of the logos. But before the historical incarnation of the human Jesus, the divine logos, according to Christian doctrine, had an important part even in the creation of the world. The logical structure, Panneberg suggests, that became manifest in the person and history of Jesus Christ should somehow be present in every creature. This means, given Panneberg's Christology, that the identity and essence of all things is realized presently only by their anticipation and will be revealed finally in the ultimate future, where the temporal will be reconstituted in the presence of the eternal. The Son and the Spirit together then act as a field of force of the divine future, from which conceptually distinct events proceed contingently. Thus, like Weizsacker and Irenaeus long before, Panneberg invokes a two-hands motif, temporality in connection with the spirit and distinguishability as relates to the logos. Moreover, interest in a history of nature, most likely according to Panneberg, determined by biblical thinking of the world in historical terms, takes into account the novelty, irreversibility of the series of ever-new occurrences that make up the world. The two thinkers thus have a single overarching concern, what it is to know in time. Famously, Panneberg reframed theological discussions on divine revelation with his view that history itself is revelation. In the sweep of history, knowledge of God by way of indirect revelation finds its eschatological culmination in the self-revelation of God. It would not, therefore, be far off to say of Panneberg's theology that at its center is an informing God. Thank you.
We have 10 minutes now for questions, so can I invite anyone from the floor who'd like to pose a question for Thomas? Yes.
Thank you very much. It's wonderful to see this spelled out, and just the book by Carl von Weizsacker that you are referring to with these 7 points, what is that?
Yeah, primarily, so he's very consistent from early on, but the history of nature from 1948.
Okay, I have that.
And the unity of nature from 1971.
Then my question is, in a sense, the time about time bridging alternatives, in a sense, brings some spatial continuity into the picture. So my general question is, what is the role of space in his sense? If he is Kantian and thinking in a transcendental way, then time and space are actually combined in Kant.
Yes.
How is it in von Weizsacker?
Yeah, great question, thank you. Yeah, so the kind of transcendental forms of intuition, he without equivocation will take time to take precedence over space. So if you know kind of the unfolding of 20th century physics where space-time, those get unified, mass energy, those get unified. Quantum mechanics in the 20s and 30s takes time, at least in Weizsäcker's construction of it, takes time to be more fundamental. So he has this question, can temporality then construct time? So he wants to say any object, which again is made out of essentially qubits, has to make decisions, not necessarily conscious decisions, but in doing so is constructing physical space. His mathematical ground for doing that is a bit technical, but simple enough. The symmetry group describing a quantum bit, which allows it to be itself under rotations in an abstract space, which is very philosophical. What can transform and remain itself, he takes as a very deep principle. But roughly that group, which is SU2, is analogous to SO3, which is just a mathematical way of saying it will actually produce three-dimensionality from the abstract space of a quantum bit. So again, if you're familiar with kind of the landscape, this was an idea that was taken up by Roger Penrose in his twistor theory. Can we take something like a two-level, your basic two-level state is like a spin-half electron, right? It's spin up or it's spin down. So Penrose wanted to construct a spinnerism. Can I take a two-level system and actually construct all of space from that? So in short, time ought to lead to space, but time is going to be fundamental.
Wonderful answer, thank you.
Yeah.
Thank you so much. I have a question concerning quantum mechanics used in this landscape. Correct me if I'm wrong, but when I tend to think of quantum mechanics, I think to particles, usually sometimes with no mass, like photons, like the two-slit experiment.
Right.
When we start to grow with the mass, so we go from the microscopic to the from the microscopic to the macroscopic, somehow this quantum mechanic effect become less kind of evident, and they say that this is the collapse of the wave function. You know, if you shoot a particle through two slits, it will go straight if the mass is big enough. And if it's a wave, it will be better. So when I see presentation like this, which I like, I always ask myself, are we dealing with something microscopic or macroscopic? Did this person here, quantum mechanical scientist, deal with the issue of microscopic versus microscopic, and also Penrose, which you just mentioned? He make a lot of argument. By my opinion, they are always based on the microscopic, and have difficulty to switch it to the macroscopic.
Yes. Yeah, great question, thank you. Yes, Weizsacker was good friends with Heisenberg and Bohr, and so the endless conversation was, how do you unite subject and object? Bohr's response, dissatisfying to a lot, he says, you have to maintain classical concepts to ask the question, which you are then seeking to answer. So he says, the way that we come into the world, quantum mechanics can emerge out of this framework, but you're always going to be asking, what's its position? What is its momentum? Weizsacker thought that that was just introducing another dualism, right, which he's trying to overcome. He's saying, now you're overcoming subject and object, but now you're introducing classical and quantum. On my own read, I don't know if he offers anything satisfying, but he certainly wants to say that he wants to introduce this very rich monism. So he wants to say consciousness, human constitution, the unfolding of time as we experience it, this doesn't fade at large quantum numbers, right? He wants to say everything is quantum mechanical. To your point about collapse, you may well know that, that's been an unfavored term in philosophy of physics for quite a while. And experimentally, larger and larger mass molecules have been shown to demonstrate that interference two-slit pattern. Whether or not that can hold, it's hard to send automobiles through a two-slit and get interference. But quantum mechanics, philosophically interpreted by means of things like decoherence, says that there is no classical instrument, right? You had people in the 60s and 70s like Wigner who would say human consciousness, perhaps animal consciousness, plants were not sure, and it really set up this very unusual bifurcation where consciousness had to step into nature to collapse the wave function. Again, that language is not favored too much anymore. Yeah.
We have time just for one more question. Anybody? Could you enlarge upon the limits of physics will have to be the limits of conceptual thinking?
Yeah.
Because we are now moving on from the middle of the 20th century, we're now moving into 10-dimensional space, 10-dimensional space-time, and that is beyond conceptual thinking. The concepts are only embedded in the mathematics. Would you say that still applies?
Yeah, if I can, attempt weakly to speak for Weizsacker, I think what he would say is mathematics, the conceptual explication of that, is precisely conceptual. It's that conceptual guide that allows you to move into the realms where you're not going to be able to have daily empirical experience, right? So when we invoke something like 10 dimensions in a very mathematical theory, you can't help but express those in general concepts, if that makes sense, right? So his whole theme is quantum mechanics is fundamentally based on symmetries. What does that mean? I'm automatically putting things under headings by which they will be understandable, right? So quantum mechanics says, well, it's a superposition. He'll say a superposition of things which can be empirically decided. The math will do what it's doing. When you interrogate nature and ask what it's doing, it will come back with an answer under some definable determinate concept. And he'll say, in a very kind of Hegelian argument, if you try and counter that, you are just introducing a category saying that you're on the other side of conceptual thinking. You are thereby in conceptual thinking.
Well, can I thank you very much?
Thank you.
For coming in.